Moore is scrutinising the sky at night.
Good evening. There's been some talk about the status of the ninth planet, Pluto, discovered in 1930. Well, Pluto has a curious eccentric orbit. It can come closer in than Neptune, and it's been doing that. But now it's going beyond Neptune again and will resume its title of the outermost planet. But is Pluto really a planet at all? It's small, smaller than our moon, so too small to be a planet, but too big to be an asteroid. Really, rather than a class of its own. But the Committee of the International Union, which I'm a member, has recommended that, for now anyway, Pluto remains classed as a planet. You may have noticed that January this year had 2 full moons, March had 2, and February had none. And traditionally, the second full moon in any calendar month is known as a blue moon, even though it's not blue. Of course, it's merely a trick of our calendar, but it's mildly interesting, I suppose. And now, on to our main theme this evening. We've been hearing a great deal about the chances of Earth being hit by a minor planet or asteroid. Asteroids come in various classes. The NEAs, or near-Earth asteroids, they can come close to us. The Centaurs, far out in the solar system. And the main belt asteroids that stay between the paths of Mars and Jupiter. And the first of these, Ceres, discovered way back in 1801. Others followed. 1807, Vesta. And Vesta can now be imaged by the Hubble Space Telescope, and we can actually follow it as it spins round. Well, in fact, asteroids in the sky appear as dim points of light, but many are now known. In 1868, we knew of 100 of them. By 1946, 2,000. By 1985, 3,000. And more are being found at a very high rate now, due largely to the coming of electronic devices such as CCDs. At this stage, I am glad to welcome back Martin Mobberley, the President of the British Astronomical Association. Welcome back, Martin. You'll agree that CCDs are making a great difference to the asteroid hunters.
Thank you, Patrick. Certainly CCDs have been a major factor. If we look first at some statistics, we can see that since the mid-1980s, the number of numbered asteroids, they're the ones with high quality orbits, has gone up from 3,000 to 9,900 today. The number of asteroids known since the mid-1980s has gone up from 6,000 to an incredible 47,000 today, an increase of 10,000 in the last year alone. You've mentioned CCDs. These have been a major factor. Not only CCDs, but also the technology that goes with them. In fact, there are now automated professional telescopes that can, unattended, discover dozens of new asteroids every single night. Also, amateurs are discovering far more asteroids. The fundamental thing is here that once you have a CCD image of an asteroid, once you have a star catalogue on your computer, once you have some processing power to determine an orbit, you can do great things. Part of the technology are these CD-ROMs, which both amateurs and professionals use. These CDs contain millions of star positions, and these are vital, of course, because the stars are the only reference points we have in the sky. Now, if we imagine an amateur discovering an asteroid as a moving dot amongst a series of CCD images, he can nowadays tell his computer to select the best image, and then also, by telling the computer where he was pointed in the sky, get the computer to recognize the stars in the field. Once that's done, he uses the mouse to click on the asteroid to tell the computer where it is, and then he simply asks for the position. And by triangulation, the computer then works out, with reference to the stars it knows, where that asteroid is. And it can be that easy to determine an asteroid's position. And once done, all the amateur needs to do is hope for some clear skies. Then over the coming weeks, he simply takes more images, gets a provisional designation for his asteroid and a provisional orbit.
Well, it sounds straightforward enough, but after all, keeping track of all these things is quite a problem, and even numbering is difficult. Will you take us through that?
Yes, getting an asteroid to numbered status is quite difficult. It takes a lot of hard work over many years. Now, the asteroids and most of the planets live in the ecliptic plane. Now, because the Earth's axis is tilted at 23.5 degrees, and we're tilted towards the Sun in summer, but away from the Sun, more towards the asteroid belt in winter, the ecliptic, because of this axial tilt, appears as a sort of sine wave in the sky. And from the northern hemispheres, the constellations like Gemini and Taurus are high up in the winter and prime areas for our asteroid hunter to search. And if we imagine our asteroid hunter from the UK searching for an asteroid in these constellations, let's say he's discovered an asteroid in early November 1998. He follows the asteroid for a couple of months through December, through to about now, January and February 99. Now, during that period, he'll have got a provisional designation, and the asteroid will have tracked about 15 degrees in the sky, the sort of width of the square of Pegasus, that kind of distance. But after January 99, he will lose the asteroid. It'll be too faint. He'll pick it up probably 15 months later, when the asteroid will be overtaken again by the Earth. But then again, he might not pick it up, because typically asteroids are discovered when they're near to perihelion. That's the closest approach to the Sun at their brightest. In 15 months' time, it may be nearer to aphelion, so he may not see his asteroid for many years. Now, because of this, it can take 10 years to discover an asteroid, or get an asteroid to numbered status that he's discovered. Now, it's remarkable, therefore, that an amateur like Brian Manning, observing from the Midlands, has managed to get 11 of his asteroids to numbered status. And Stephen Laurie, another amateur, has discovered 65 asteroids and already has got one of his asteroids to provisional status. Once the amateur has got his asteroid to numbered status, he can then propose a name for that asteroid.
Yes, indeed. And when Brian Manning found his first asteroid, he named it after you. Named it Mobberley, didn't he?
That's
What's
right.
your number?
I'm number 7239.
I'm 2602, newcomer. What about provisional designations?
Well, provisional designations are important. Now, with maybe 30 asteroids being discovered every single day, it's necessary to have some kind of designation system. And we'll start with the example of 1997 XF11. Let's see how that's constructed. Obviously, the first 4 digits are the year in which it's discovered. Then we have a letter. This denotes the 2-week period during the year when the asteroid was discovered. In the case of X, it stands for December 1st to 15th. If it was XA, it would be the first asteroid discovered in that period. XF would be the 6th, and XZ would be the 25th. There's no letter I in this alphabet. After XZ, we come to XA1, and the 1 basically means we've already been once through the alphabet. If we run on to 1997 XF11, we've gone 11 times through the alphabet, stopping at F, and we've covered 281 asteroids, which does show you just how many asteroids are being given provisional designations, and most of these end up as new discoveries. And there are some 50,000 asteroid measurements every single month being forwarded to Brian Marsden, shown here, and his deputy Gareth Williams at the Minor Planet Centre, and they put this data to very good use indeed.
They do indeed. And now, thanks to spacecraft, we can get close-range images of some of these asteroids. Let's have a look at a few, shall we? Here is Gaspra, shaped rather like a potato. Here is Ida, several views of it, irregular in shape, spinning round. There's a better view of Ida. Looks like a little dot on the right-hand side there. That is Ida's tiny mile-wide satellite, Dactyl, and there's a close-up of Dactyl. Then we have Matilda, almost coal-black with large craters in it. Recently, a spacecraft near the Near-Earth Asteroid Rendezvous was sent up to rendezvous with the tiny asteroid Eros, less than 20 miles long, and although the first approach didn't work, we have got pictures now of craters there, and we hope to have a close approach later on. But these near-Earth asteroids are small. Compare them, for example, with the Isle of Wight. They're pretty small things. On the other hand, they will make a very considerable crater if they happen to hit us, and there are plenty of them.
Yes, in fact, ever since Shoemaker-Levy 9 collided with Jupiter in 1994, we've become far more aware of the hazards that are out there. In fact, the near-Earth asteroids are generally under 5 kilometres in diameter. They're split into 3 categories. Firstly, the A-10s. Now, they spend most of their life inside the Earth's orbit, but they cross it as they move out to aphelion, or furthest point from the Sun. Then there's the Apollo asteroids. They spend most of their life outside the Earth's orbit, but cross it as they move in towards perihelion, or their closest point from the Sun. And then there's the Amors, which don't actually cross the Earth's orbit. They can come pretty close, though, and many of them in thousands of years, as their orbits change, will cross the Earth's orbit. In fact, their perihelia are less than 1.3 AU. Some people call them Mars crossers. Now, the two telescopes that excel in this kind of asteroid detection are the Spacewatch telescope in Kitt Peak, Arizona, and the Linear telescope, or Lincoln Laboratories Near-Earth Asteroid 1-meter telescope at Socorro, New Mexico. Both these incredible telescopes have discovered about 100 near-Earth asteroids each. In fact, both Linear and the NEAT telescope in Hawaii were originally set up by the US Air Force to search for Russian satellites in orbit, but they're equally good at detecting moving near-Earth asteroids. The Linear telescope is quite incredible. In the past 2 years, it's discovered 15,000 asteroids, and last year alone, it discovered 16 new comets, which is amazing. Now, Spacewatch has been doing this for 10 years, and the Spacewatch telescope took this remarkable image in 1994. 2 near-Earth asteroids discovered on the same CCD image, asteroids 1994, GK and GL. And here we see Jim Scotty standing next to the 0.91 metre Spacewatch telescope. He's personally investigated 60 discoveries made with his telescope's software. In fact, the strategy for discovering NEARs is different to discovering main belt asteroids. Because NEARs come close to the Earth, they can appear in virtually any part of the sky. So the strategy here is to search the sky as quickly as possible, typically with 2 or 3 minute exposures, but coming back every 30 minutes or so to the areas imaged earlier in the evening and looking for any object with consistent motion that could be a near-Earth asteroid. Now, the exciting news here is that there is going to be a second Spacewatch telescope, twice the aperture of its predecessor at 1.8 metres. Because of this larger aperture, this will not only search for near-Earth asteroids, but it will also search for centaurs and trans-Neptunians at the very edge of the solar system. Now, it's interesting to compare Linear and Spacewatch discovery statistics. We now know of 45 A10s. And in 1998, Linear discovered 10 new A10s compared to 1 by Spacewatch. And that kink in the graph is when Linear was switched on in April 97. And a similar thing is seen with the Apollo and Amor statistics. We now know of over 300 Apollos and over 300 Amors. And in 1997 April, Linear was switched on, and here we see how the rates went up. Last year, Linear discovered 55 Apollos to 21 by Spacewatch. And a similar story with the Amors. Linear discovered 58 new Amors in 1998 compared to 14 by Spacewatch. But amateurs can also image near-Earth asteroids, and here are a couple of images of mine. One taken in 1993 of 1993 MF, and one of Tutatis I took a couple of years ago. Now, this asteroid Tutatis will come within 1 million miles of us in September 2004. Now, when it came close in 1992, the Jet Propulsion Laboratory remarkably managed to bounce radar off Tutatis and map its surface. And here we see the result. It shows an incredible object several kilometres across, a sort of strange dumbbell shape. Now, since 1988, amateurs have been discovering near-Earth asteroids as well. First the Japanese, then the Italians, and now the Americans.
Yes.
And the world leader in this field is Roy Tucker. He has an observatory in Tucson, Arizona, and it contains a 14-inch Schmidt-Cassegrain telescope. His first discovery of a NEAR was 1997 MW1. Now, he's actually discovered 2 A10s and 1 Apollo, which not only is an incredible achievement from an amateur, it's also won him $1,500, because the Benson Prize was set up a few years ago to reward $500 to any amateur who could discover a near-Earth asteroid. So he's doing very well indeed.
He certainly earned it. Do you remember 1997 XF11? Small Earth crosser, and thought possibly that it might even hit the Earth in the year 2028 and cause quite a stir at the time. Well, I'm glad to say, orbit now recalculated, it'll miss us by at least 800,000 miles, so no panic. But of course, a little while ago, I flew over the large crater in Arizona. There it is, nearly a mile wide, and that was certainly made by a massive body that hit the Arizona desert about 50,000 years ago. And let's be honest, Martin, the chances may be small, but we could be hit by one of these things.
Well, the risks are small in any one person's lifetime, but it's nice to have some kind of insurance policy, and the insurance policy we've got is to discover as many threatening asteroids as possible. Now, the Minor Planet Center has devised the term PHA for potentially hazardous asteroids. We now know of 160 of these, and a PHA is any asteroid more than 200 meters across that can come within 5 million miles of the Earth over the next 200 years. The largest that we know of was discovered last year by Linear, and it's 1998 QS52, and that has a diameter probably of about 6 kilometres. Now perhaps the best known potentially hazardous asteroid, number 3, is Hermes. That passed close to the Earth in 1937 and raised some interesting newspaper headlines.
I remember that very well indeed.
And if we look at a chart showing the notorious close approaches of asteroids to the Earth compared to the Earth-Moon distance, we see that the record holder is 1994 XM1. Only 10 metres across, discovered by Spacewatch in '94, that came within 65,000 miles. And Spacewatch took this discovery image. Now, far more disturbing than that small object was 1996 JA1. And a few years ago that came within 280,000 miles and was a whopping 350 metres across. So if that had landed in your back garden, I think you'd be claiming on the house insurance.
So do I.
Now, Hermes we've already mentioned, and in 1937 that came within 500,000 miles. That was probably about 1 kilometre across, but the worrying news here is that we didn't measure enough positions then. We don't know exactly where it is.
It's lost.
We've lost it. Now, comets can also come close to the Earth, the record holder being Lexell, which came within 1.4 million miles in 1770. Iris-Araki-Alcock came within 3 million miles in 83, and Hyakutake 10 million miles in 96. But comets like these come from the far outer reaches of the solar system. We don't generally know they're coming until weeks or months before they arrive. And the damage from an object kilometres across, travelling typically at 30 kilometres per second, would indeed be horrendous, as shown in recent films. Now, astronomers calculate that on average, objects of a few hundred metres in size will probably hit the Earth every 10,000 years, and objects of 1 to 2 kilometres in size probably hit the Earth about every 1,000,000 years. The Space Guard Foundation is worried about this, and so it set up a target for astronomers to discover 90% of the near-Earth asteroids larger than 1 kilometre in diameter by 2007. And indeed, NASA has adopted this ambitious goal.
Well, you know, so far we've got 10,000 numbered asteroids and a total of 50,000. How much longer is this going to go on, do you think? How many of these things are there, Martin?
Well, I think with the fantastic telescopes like Linear, we'll discover many more, and in the main belt there could be hundreds of thousands of very small asteroids. As far as NEARS are concerned, astronomers now think that we only know of 10% of these. We've got 90% to go. So there could be 2,000 potentially hazardous asteroids out there. Fortunately, the internet is a superb source of information. Linear, Spacewatch and the Minor Planets Centre all have their own web pages. We can only wait and see what happens and watch how the numbers rise and see just how many large asteroids there are in near-Earth orbit, near-Earth asteroids, and see just how many of them are passing rather worryingly close to the Earth in years to come. We can only wait and see.
And hope for the best. Martin, thank you very much. You know, when I was a boy, I read my first book on astronomy, and there was a bit about asteroids, and I remember the passage, "These tiny bodies are of no interest to the amateur observer, and really no interest to anybody." How wrong they were. Martin, thank you very much. Now, Martin mentioned our website. We've improved that now. You can find it on www.bbc.co.uk/sky at night. And of course, our information line, 0891 800 330, or CFAX page 620. And when I come back next month, I'm going to go right outside the solar system into the depths of space. I'll be joined by Dr. Helen Walker, and we'll talk about what happens when stars grow old. Until then, good night.